hardware limits for local models. The pursuit of running larger language models locally continues to highlight the intricate balance between hardware capabilities and model requirements. A retired electronic engineer upgrading from a Dell laptop with RTX 3050, 6GB RAM, to a desktop with RTX 5070 Ti, 16GB RAM, and 128GB RAM sparked detailed community analysis about feasible model configurations. The consensus suggests that while 16GB VRAM isn't sufficient for good dense models above 10 TPS, mixture of experts MO architectures offer a promising alternative. Specifically, GLM 4.5 Air 106B12A emerges as a top recommendation, with UDQ4XL quantization achieving approximately 10 TPS and UDQ6XL around 4 to 5 TPS. However, RAM bandwidth becomes the critical bottleneck. With the i9-13900K's 89.6 GB per second limiting dense model performance. For instance, a 70B Q8 model would only achieve about 1.3 tokens per second regardless of GPU offloading due to Amdahl's law constraints. Meanwhile, another user showcased the NVIDIA RTX Pro 6000 Blackwell Server Edition, $7,600, demonstrating impressive thermal management when paired with high CFM server fans, achieving 140 tokens per sec with NanoNet's OCRS, while maintaining temperatures under 62 degrees Celsius under load. For those running smaller models, performance expectations don't always scale linearly. A user experimenting with Qwen 2.5b discovered they only achieved around 300 tokens per second, despite theoretical calculations suggesting much higher throughput based on memory bandwidth. The explanation appears to be that once models become small enough, the limiting factor shifts from memory transfer to actual compute power, with matrix operations completing so quickly that unloading without custom CUDA becomes the bottleneck. This has significant implications for audio-related models like Voxtral, Cosi Voice, and Orpheus, where latency is paramount and 300 TK still may not suffice. For larger models like GPT-OSS 120B, users with RTX 4080, 16GB VRAM, and 64GB RAM find success by strategically offloading expert layers to CPU while keeping others on GPU, achieving 7 to 10 tokens per second. The community recommends using the CPU MO flag in llama.cpp to control expert layer distribution between CPU and GPU resources. Optimizing MOE model inference. Optimizing mixture of experts models reveals another layer of complexity in local AI deployment. Users running massive models like Qwen 3235B and GLM 4.5 on systems with dual 3090s, 28GB RAM, and Intel 12700 processors report achieving only 2 TSEC output with 38 TSEC evaluation on Q2K quantizations. The current best practice involves setting override tensor equals 04 plus FFN to XP equals CPU in extra flags while maximizing GPU layers, though the community continues to refine these parameters. Meanwhile, new tools are emerging to streamline model serving workflows. The VLLM CLI project offers a rich terminal interface with menu-driven navigation for model selection, configuration, and real-time monitoring. This tool provides both interactive and command line modes with automatic discovery of local models, support for serving directly from Hugging Face Hub without pre-downloading, and comprehensive server monitoring showing GPU utilization and streaming logs. The CLI includes 4 pre-configured profiles optimized for different use cases, with particular attention to MOE models where expert parallelism can significantly improve performance. The landscape of AI development tools continues to evolve rapidly. The Claude Flow project released Alpha 90, representing a major quality update implementing 15+ real MCP model context protocol tools while reducing mock implementations from 40% to under 5%. This update includes fully implemented DAA tools for decentralized autonomous agents, a complete workflow engine with execution tracking, and performance tools using real metrics rather than simulations. Critically, the team discovered that the neural tools were actually using the Fast Artificial Neural Network (FAN) engine, indicating real neural network processing rather than simulations. Alongside these developments, the community continues building specialized tools like Subhunter, a passive subdomain enumeration tool that scans across different sources to discover subdomains while offering configurable rate limiting and validation options. New models push performance boundaries. Moonshot AI has unveiled Kimi K2, a state-of-the-art mixture of experts language model with 32 billion activated parameters and 1 trillion total parameters, demonstrating remarkable performance across frontier knowledge, reasoning, and coding tasks. Trained using the Muon optimizer on 15.5T tokens, the model achieves 53.7% on LiveCode Bench v6, outperforming DeepSeek v3, 46.9%, and Qwen 3235B, 37%. Particularly noteworthy is its agentic coding performance, achieving 65.8% pass 1 on eBenchTime, verified with Bash editor tools in a single attempt, surpassing Claude Sonnet 50.2% and Opus 53.0% according to the reported benchmarks. The model also excels in tool use tasks, scoring 70.6% on Tau2 retail benchmarks compared to Claude Sonnet's 75.0%, while significantly outperforming alternatives in telecom scenarios, 65.8% versus Claude Sonnet's 45.2%. These results suggest the Muon clip optimization techniques developed by Moonshot have successfully addressed training instabilities typically encountered at this scale. In multimodal AI research, the introduction of JWB DHV1 benchmark addresses critical gaps in evaluating joint whole-body talking avatar and speech generation. This comprehensive benchmark comprises a dataset with 10,000 unique identities, 2 million video samples total, featuring fine-grained annotations including body segmentation, landmark annotations, and motion text describing pose semantics. The evaluation protocol employs specialized metrics for both video generation, subject consistency, background consistency, motion smoothness, and speech audio, using large audio language models rather than traditional WER. The evaluation of state-of-the-art models revealed consistent performance disparities between face, hand-centric, and whole-body performance, highlighting that models excelling at facial animation often struggle to generate full-body motion properly synchronized with speech, a crucial insight for future research directions. Meanwhile, specialized models continue to emerge in niche domains, including Kitten TTS, a text-to-speech model with just 15 million parameters, under 25 megabytes, designed for lightweight deployment without GPU requirements. Another specialized release is the Overlay Context Dev LoRa, fine-tuned on Black Forest Labs' Flux.1 Context Dev for seamless image overlay tasks, enabling natural integration of new elements into existing scenes using the trigger phrase, "place it." Automation bottlenecks shift to context engineering. Despite impressive advancements in model capabilities, fundamental constraints in AI automation are shifting from raw intelligence to specification clarity and context management. A recent analysis argues that while models continue improving on reasoning benchmarks, including OpenAI and Google models performing at gold medalist level in International Mathematical Olympiad 2025, enterprises struggle with relatively simple automation tasks due to specification gaps and scattered local context. The quality equation reveals why mathematics presents relatively easy targets for AI progress. Formal specifications with no gaps allow models to optimize for intelligence alone, whereas real-world business tasks involve moving systems with fuzzy specs and context scattered across documents, inboxes, and people's heads. This creates asymptotic improvement curves where increasing model intelligence yields diminishing returns without corresponding improvements in specification quality and context accessibility. Addressing these challenges requires new approaches to context management. Users Denzai experimenting with RAG systems combined with Wikipedia dumps to keep AI models informed, though vector database scalability remains a concern as build times and search latency increase with data volume. Meanwhile, developers are working on constraint-guided knowledge files to reduce long-chain drift in Claude, though specific implementation details remain under development. On the application front, a senior finance leader seeks to reduce financial model deployment time from 5 to 10 days to just 2 days using automation tools like Klein for SQL generation, alongside integration with Tableau Sigma and structured README documentation to help AI agents understand project modules. Similar challenges appear in coding environments, where users attempt to mimic custom slash commands from Claude Code within Aider, seeking ways to maintain context across multiple project files without manual copying and pasting. The regulatory and technical landscape continues evolving outside pure AI development. Google Play Store's new policy requiring wallet developers to obtain banking licenses effectively bans non-custodial wallets by imposing unmeetable compliance requirements. This policy ignores the distinction between custodial and non-custodial software clarified by FinCEN regulators, effectively forcing AML KYC frameworks on decentralized software through monopoly power rather than legal requirement. In gaming and security, hardware hacks demonstrate ongoing cat-and-mouse dynamics, including a physical aimbot for Valorant that uses YOLO object detection with a mechanical CNC platform to control mouse movements, bypassing anti-cheat RuntGent by mimicking human input patterns. Meanwhile, new interface paradigms emerge with Markdown UI, enabling interactive UI elements within Markdown documents for LLM interactions. And network security tools implement OpenBSD's pflog functionality in Linux, NF tables for better firewall logging capabilities.